Welcome back. My name is Andy Harris. I'm the author of the simpleGame.js library, HTML5 game programming for dummies, and a number of other books on game development and web development. In the second tutorial, I'm going to show you how to build a little interactive toy here with the simpleGame practice tool. In the last episode, I showed you the basics of getting an object up on the screen and able to do something interesting, that is, just move around. In this second tutorial, we'll add user interactivity. So if I press the up arrow, my car will move forward. If I press the left arrow, the car will move to the left. The right arrow, the car will rotate to the right. It's not terribly realistic, it's not absolutely a perfect little thing, but considering that it's pretty easy to build and it's the foundation for all kinds of more interesting behavior, well, let's take a look at this and see what we can do with it. As before, the tutorial is based on this simpleGame practice tool. You can get that from my website, www.aharrisbooks.net. You can look either at the HTML5 game programming for dummies site, or I'll have a more prominent link on my main page. And when you look at this tool, you'll see several sections that I described in the last tutorial. On the bottom here, you'll see some buttons. By the time you look at it, I may have added some others, just because it might be fun to have some other demos. The Run button runs whatever is currently entered here. It creates a web page and pops up that web page in a new window. These other two are sample programs. Last time we looked at the ball. This time we're going to look at the car sample program and see exactly how that works. Indentation is off a bit. Okay, so the car is the program that I just showed you. Let's run it again, and we'll see there is indeed a scene. That's the background. And there is a sprite. Sprites are objects that can move around. And you can see my car is this time moving under user control, different than what we saw last time. Alright, let's take a look and see what we can do with this. Well, first we begin with a review. There's a scene object, there's a car object. In the variables section, we simply create the objects that we need. And you'll see here, when this gets turned into actual JavaScript code, that's exactly what happens. We create a scene in a car. Now in the init function, that's where we're building everything. And typically what we do is we build the scene and then we build the sprites. It starts out in a way that should be familiar to you. Scene gets new scene. Okay, create a scene. Nothing surprising there. The second line, car gets new sprite. What that does is that creates, well, a sprite object. Remember, the sprites are the things that move around and bonk into each other. A sprite needs to have 4 parameters. It needs to know what scene it belongs to. That's the scene. It also needs to know an address where the image file can be found. Again, this is an image I created. Although it's very easy to steal any image you want off the internet, you really ought to use an image that is royalty-free so you're not using someone else's intellectual property. Easiest way to do that is to create your own. In the book I'll show you some how to do that, and I'll also show you some wonderful places where you can get some free images to work with. Then the last 2 parameters are the width and the height of the sprite as you want them on the screen. And if you're not sure at first, you can play around with these things and modify them later. Now the next thing I do is I'm going to set the car's initial speed to 0, because this time I don't want the car driving around on its own. I want it to be moving based on, well, user input. Okay, that makes sense. Now finally, I've got this complicated thing going on here. Car.checkKeys gets function, and that goes all the way this whole chunk. Well, we're going to come back and look at that in detail, but here's the big picture of it. What I'm doing here is I am assigning to the car a new behavior. In the kind of programming we do in most gaming, called object-oriented programming, you can treat something like an object, which means not only can you change characteristics of that object, like its speed, but you can add new behavior to it. Oh, that's a really powerful idea. And that's exactly what we're doing here. I'm telling the car, hey, I'm about to define what it means to check the keys. Later on, when somebody asks you to check the keys, this is what I want you to do. We'll come back and see what that means, but take a look at update so you can see what's happening. Here in update, I've got a scene.clear, car.checkKeys, car.update. Let's review what each of those things does. Scene.clear says, hey, clear the scene. Erase everything before we start drawing stuff. Check keys calls this new function I've just created. It says, hey car, check your keys and respond as necessary. And then this third line, update, that is what actually draws the car. Now to just reinforce this, let's try something sneaky. I'm going to use the comment character, that's 2 slashes, to make the scene.clear go away. So it's still there, but it's going to be ignored by the computer right now. This is a very handy technique among programmers when they're testing their code. And I'm going to run the code, and we'll take a look, and so far it doesn't look like anything has changed. But take a look at what happens when I drive the car. Oh, that is probably not what we intended, although it's a kind of a cool effect. What's happening here? Well, see, every time I update the car, it's drawing. That's all an update does, is it draws that car on the canvas. The thing is, without the clear, I'm drawing it on top of something where it was already drawn. Oh, yeah, it's pretty crazy. So why you need the update is, or why you need the clear, is because we're telling it, hey, before I draw the stuff from this frame, erase what was already there, please. And so that's why we need that update. Although I kind of like this. I call this green dragon in the morning. Alright, so let's go back and we'll change that clear. We'll take that, put that back in so we don't see that effect anymore. And now we should be fine. Alright, notice something else here that's happening is that my car seems to be running more quickly than it was before. Now this is an artifact of the practice tool. It's not a problem with the game engine. And what I've noticed is you can keep running without closing this window and it'll do fine, but sometimes the timer gets messed up. So if you're finding that you're having some strange issues with the speeds of your games, make sure you close this window down all the way before you restart it, and that should take care of all those things. Now my car is working at a normal speed. It's not showing me all of the ever cars that have been drawn. It's just showing the current one. Okay, that's good. Now what if I took out car.checkKeys? Well, we can try that. And here's what would happen. The car will sit there. I can press the keys all day, but it won't do anything because, well, I haven't told it, hey, check the keys. I've told it how to check the keys, but I haven't told it to do so. What about the update? Now this one will drive you crazy because if you forget to do the update, you'll think that your whole code is broken. And it is, but it's broken in a very easy way. I've done all the work to define the car and tell it what to do, but I've neglected to tell it to draw itself. So the update draws the car on the screen, and that's a really important thing. If you forget that, if you're looking at a blank screen, well, that may be one thing to check. Make sure you're actually, well, remembered to update the car. Okay, I have all these components in place again, and we'll run it and see how's it working. Okay, that's all good. Now, that's all very well, but what is checkKeys doing? Well, it's doing quite a lot. And it's introducing some really important new ideas in computer programming. Now, if you're an experienced programmer, this won't be too shocking to you. If you're not, well, today's the day you become one. We start learning about some of the most important ideas in programming right here, right now. So, under checkKeys, first of all, I'm defining that as a function. What I'm saying is all of the code in between this left squiggle brace and the upcoming right squiggle brace, all that stuff is special. That is code that will happen whenever I say, hey, I want to check the keys. So the squiggle braces are very special, and the languages derived from C, which is many of them. What they indicate is that we're going to be doing something special with the intervening code. The other thing you'll notice is that I have indented everything between the function statement and its right brace. And that's a pretty standard thing that programmers do. The programming language usually doesn't care, but every programming teacher I know, including me, and every programming boss that I know, including me, pretty much requires this. So it's a good habit to get into. The indentation helps you know what's happening, so you really, really need to indent typically 2 or 4 spaces inside every function. There's some other places to indent. I'll tell you about them as we get to them. Now the first thing I'm going to do is set the car's speed to 0. Now, okay, set speed 0, we know that one, right? That says, hey, stop it. But what's the this? Okay, to tell you the truth, I could have gotten away with calling it car.setSpeed 0. And that would be fine. That probably would make more sense to you right now. And it's true. I want the car's speed to be set to 0. But because we're going to be doing some more elaborate work later, I would prefer to use a special keyword this. And this refers to the thing I'm currently defining. In this case, the car. So we'll say this.setSpeed, which means car.setSpeed. It's okay if you don't exactly understand what I'm talking about at the moment. Just go with me here. As we are creating more elaborate objects, the use of the this keyword will make a little more sense to you. But for now, we're just going to go with it. So I'm using this inside a function definition. Alright, so set the speed to 0. Why I'm doing that is that I want to assume at the beginning that the car's not moving. The car will only move if the up arrow is currently being pressed. So here's the basic idea that I'm thinking through this function. Start by saying, hey, car's not moving. Then, if they press the up arrow, we'll move the car forward in the direction it's currently pointed. If the left arrow is pressed, rotate the car to the left. If the right arrow is pressed, rotate the car to the right. That's the algorithm, that's the plan. Now the code here is simply an expression of that plan in the format that my particular library and language wants. Okay, let's see how that works. Begin by assuming the car is not moving. There's that line right there. That's pretty easy. Now there's a lot going on this line right here. One of the most important ideas in computer programming, but it's really cool. First thing we've got is this special keyword, if. Well, you've probably used that in English, probably today. Now, if it's raining, I'm going to carry an umbrella. If it's nice outside, we'll have a picnic. So, okay, those are great. What does the if keyword do? Well, it always sets up something called a condition. And a condition is nothing more than a true or false test. So, is it raining? That's true or it's false. Is the temperature above 80 degrees? So it can be a comparison. It can simply be something that's true or false. In this case, what am I checking? Well, something kind of clever. What I've set up here in this game engine is a special tool called keys down. And what keys down does is it tells me the status of every key on the keyboard. So keys down tells me what's going on with the entire keyboard. And it has a lot of pieces. Well, in the square braces, I tell it which key I'm interested in. K_up is a special code for the up arrow. They all begin with K underscore. They all have uppercase letters. It's a tradition in programming. K_left is the left arrow. K_right is the right arrow. The regular keys are K_A through K_Z. And there's others, space bar, escape, and so on. You can look them up in the documentation. Now here's what's going on. If the key at the up arrow is pressed, keys down, square brace, K up, well, that will be true. Aha! The thing inside the parentheses of an if statement always has to evaluate to true or false. Well, keys down is designed exactly that way, so that if the up arrow is pressed, this value is going to return true. If the up arrow is not pressed, this value will return false. Look later in the book, I can explain exactly how that works, but right now that doesn't matter. What really matters is, hey, it produces a true or a false. You following me? Okay, cool. So we've got a true if the up arrow is being pressed and a false if it doesn't. Now here's what's so fun about an if statement. The if statement has the keyword if followed by a condition inside parentheses. That's something that boils down to true and false. And then it has a new set of squiggle braces. Okay, so the squiggle braces here say, hey, if the condition was true, I want you to do the code inside me. So this code, the this.setSpeed5, that happens only if the up arrow is currently pressed. If the up arrow is not pressed, the condition is false and that code just gets skipped. You can have several lines of code in there. For now, I only need one. But the really exciting thing about an if statement is this is how computers appear to make decisions. You set up a condition, and it checks the condition. If the condition's true, we do something. If the condition's false, we skip along. There's more to conditions, but for now, this simple definition is fine. Okay, that makes sense. Now what do we do? Well, if the up arrow is pressed, set the speed to 5. That means, hey, move 5 pixels. Pixels are those little dots on the screen, remember. Move 5 pixels in the direction we're currently pointed. Oh, that makes so much sense. And it maps directly to what we want the ball to do, or the car to do, and that is, if I press the up arrow, I want the car to move in its current direction. When the direction changes, I want the car to move in its new direction. In fact, I can do both left, right, and up, but don't worry about that too much. Okay, so it is doing what we want it to do. Now let's take a look at the other conditions. So after I'm done checking for the up arrow, now I look for the left arrow. If the left arrow is pressed, what do I want to do? Well, change your angle by -5. I got to talk about angles here a little bit. First of all, remember that the change angle changes both the angle that it's pointing and the angle that it will move if its speed is non-zero. Okay, that makes sense, I guess. And the angle is measured in degrees, in the normal form of degree measurement that you're used to from navigation. That is, 0 is right, and increasing measurement moves in the clockwise direction. Positive angles move in the clockwise direction. Changing by a negative value goes in the counterclockwise direction. For those of you who know a little math, you might be saying, seriously, you're not using radians? Well, don't worry, I am using radians underneath, but I decided to not add that confusion here. Later on, as you're looking at the actual code of the library and want to learn how to do things more precisely, we do in fact use radians. They're actually a much better measurement. But for now, I thought it was easier to go with angles the way that most people are familiar with them. Okay, well that makes plenty of sense. We check for the up arrow, and if so, set the speed to 5. If the left arrow is pressed, change the angle by -5 degrees. If the right button is pressed, change the angle by +5. Now at the end of an it, we start the scene, and that creates this ball. No, the car. I should figure out what program I'm writing. And there it goes. We can create a car that drives around on the screen. And you shouldn't trust me on this. You need to run this yourself. You need to get out there and you need to try and make this code happen. You look at it yourself, change it, make it turn faster, make it turn backwards, put your own images in there. Have a great time. Have all kinds of fun with it and see if you can figure out how to make it do everything that you want it to do. And come back next time and we'll learn how to build a complete game with collisions, custom objects, sound effects, and the whole deal. You ready for that? I'm ready for that. See you next time.